So, ready for a new chapter, chapter 6, rational exponents and roots. And we're going to jump right into 6.1, which is rational exponents. Page 493 is where that starts. The actual discussion is going to take place on 494. So, a couple of the things that you've learned over the years when you've done algebra is how to undo things. So, for example, if we're trying to undo the plus 3, we subtract 3 from both sides. In order to undo multiplication, we divide. In order to undo division, we multiply. So there's always something out there that we can use to undo what we did. And that's the way this section goes when it comes to exponents. So if we want to square 3, that symbol means we take 3 times 3 and we get 9. Now if we want to go back to our original there from 9 to 3, we do what is called take the square root of 9. So that means what number times itself is going to give me 9? And that's 3. So we square 3 to get 9. We take the square root of 9 to get back to our 3. That's pretty much what it looks like. So if we have the square root of 64, that means what number times itself is going to give me 64. And there's pretty much a bajillion numbers that you can take the square root of to get back to where you begin. All right, so let's get moving with some of these. And, let's do some definitions here first. I don't know when they're going to start doing this in the book, but I'm going to start now. The number that goes in here is called an index. This number is called the radicand. And this sign right here is just called the radical sign. Now, when we don't put an index in here, it's an assumed 2. Just like we don't write 1x because it's an assumed 1 there. So same is true here. It's an assumed 2. If we had something like a 3 there, it means what number times itself 3 times is going to give us our radicand, the number in there. So we can also have the 4th root. What number times itself 4 times? In this case, 2 times 2 times 2 times 2. And you can have pretty much any number you want in there, in that index position. Probably just to set the record straight, just a couple kind of odd ones to put in here. Also, cubed root of 0, cubed root of 1, 4th root of 1, 4th root of 0, all equal 0 or 1, respectively. If we have something like a square root of -4, that says what number times itself gives us -4. And a lot of people jump to, -2. Well, -2 times -2 is a positive 4. 2 negatives give you a positive. So when there's a negative sign under there, it is not a real number. There's no real number whose square is -4. But if the index is a 3, you can have a number that works with a negative. So, for instance, -2 times -2 times -2. This gives me a positive 4, and then when I multiply it by -2, I get my -8. So if my index is an odd number, there can be a negative symbol in here, and there is an answer. negative 2 for this one. If there's an even number, like in this case a 2, there is not a negative that works. So just something to consider. When we have something like this just means the negative square root of 25. So we take the square root of 25 and this negative goes right there. So section B is talking about what do we do if we have a variable under the radical sign. Or two variables. So the square root of 25, a to the fourth, b to the sixth power. What I do here is I just tell my students to take the square root of the number, and then there's a 2 here, right? I divide 2 into 4 and 2 into 6, and I'm done. That's all there is to that. If I have the cubed root of x to the 6th, y to the 12th, same thing. 3 goes into 6 twice, 3 goes into 12 4 times. And the radical disappears whenever you do that. And last one, fourth root of 81, R8, S20. So, fourth root of 81, 3 times 3 is 3. 4 goes into 8 twice. 4 goes into 20 5 times. And that's it. Not too terribly hard when you're talking about variables under the radical sign. You just take the index and see how many times it goes into the exponent, and that ends up being what you've got. And the radical sign disappears. Now we will get into some where the 4 does not go into the exponent evenly, and then we've got a different thing on our hands, but we'll get to that later. Right now, just enjoy the simplicity of just being able to divide like that. And that brings us to C, rational numbers as exponents. Rational numbers as exponents. Pretty much that just means that there are going to be times where we get numbers like that. And a lot of times, the reason that we use a fraction as an exponent here is it becomes very, very easy then to solve. Because what happens is this number down here is the index. So what this is doing is this is the same as the cubed root of 8. And this number here is the exponent on the number that we're talking about right here. So that's going to be a 1. So 8 to the 1/3 power is the same as the cubed root of 8. So another one, for example, if I had 6 to the 2/3, that means my index is the bottom number, 6, and the top number is that. So it's actually the cubed root of 36. Okay, hopefully you can hear me over my wife vacuuming out there. So what if I have negative 25 to the 1/2 power? Okay, this negative sign is not part of that 25. It's just saying take the opposite of the 25 to the 1/2 power. So what happens here is my index is 2 from here. My 25 is here. It's got an exponent of 1, which means I don't have to show it. And that negative is right there. So that equals negative square root of 25 is 5. Okay. If I have this, that is the same as, which cannot be done. If I have 4/9 to the 1/2 power, that exponent is on both the 4 and the 9. And And that basically means square root of 4 over square root of 9, which is 2/3. All right, let's just keep moving along here. At the top of page 497, it says if A and B are real numbers. Okay, it just gives you a review of what we have done in the past, just as a reminder, because as we continue going through here, we will be using those properties of exponents with our radicals. So let's jump down to number 15. We have the cubed root of x to the 6th, y to the 12th. And it says write each radical with a rational exponent, then simplify. So what they want us to do is take the square root sign off, or the cubed root sign off, and write with a rational exponent of 1/3. Now remember, on some of these old ones I did, or just a few minutes ago, we simplified this by seeing how many times 3 went into 6, 3 went into 12, was able to take our radical sign off and put a 2 and a 4 there. Same can be done with this. We take, remember the exponent here and the exponent here, and there's a parenthesis separating, that means multiply. So that's going to be and then this is going to be 6 over 3 is 2, 12 over 3 is 4. Same thing. But there is a reason for this. There are some problems that you're going to get into regularly that you don't want the square root sign on here. You want to deal with exponents. It makes life so much easier when you're able to deal with exponents. So let's keep going here on 16, and then we'll stop and start a new video. Okay, so again, 4 goes into 8, 4 goes into 20. We could do that, but let's do it with exponents. So we have 81R8S20, and that's to the 1/4 power. So then we take the 4th root of 81, which is 3. We take 8 times 1/4 and get 8 over 4. And 20 times 4, we get 20 over 4. So that gives us 3r squared s to the 5th. Okay? So just practicing using those exponents, those fractional exponents. Okay, I'm going to stop here and start the next video in just a minute.